So imagine you've been in some kind of severe, really chaotic situation.
Like a car accident or something.
Exactly, an accident, maybe an immediate threat.
Right.
And you react, you get out, you're functional, you escape.
Right.
And then only when you're finally safe and that adrenaline starts to dip, you suddenly feel this excruciating pain from a catastrophic injury you didn't even register. A broken bone, a deep wound, your brain just held it all back.
Well, that's one of the most compelling mysteries, isn't it? How can the brain actively choose to just disregard objective physical reality?
Yeah.
How does it have the authority and the mechanism to unilaterally hit a mute button on a pain signal that should be screaming through your nervous system?
And that is precisely our mission today. We're going to take the source material and go way beyond the simple, it's just adrenaline explanation.
Good.
We're diving into the incredibly sophisticated, intentional mechanism the body uses to turn pain off during moments of extreme danger. It's a blueprint for survival.
And we really need to frame this correctly from the start. This isn't a fluke, or some lucky medical anomaly.
Right.
This is a highly evolved, active survival function. It's the brain performing this immediate emergency triage. It's basically saying, we'll deal with the body damage later.
Only once we're a safe distance from the threat.
Exactly.
Okay, let's unpack this just incredible ability. We've all heard those stories, right? The person walking out of a wrecked car who seems fine, or the athlete finishing a game on a broken leg. Our sources point out that this is all orchestrated by a very specific, dedicated feature of the nervous system.
That's right. I mean, we often talk broadly about the central nervous system, but this function it's specific. We can kind of visualize it, as the source describes, as the pain shutdown system.
Big shutdown button.
A pain shutdown button. But to move beyond that analogy, we have to look at the command center.
Okay, so if the shutdown is a button, where's the switchboard? Where is this happening?
The control center for this immediate emergency analgesia, it's primarily housed in a dense cluster of neurons called the periaqueductal gray.
The PEG.
The PEG, yeah, located in the midbrain. The PEG is the critical nexus here. It receives all the incoming sensory signals about danger and injury, and it makes the instantaneous, high-stakes call.
The call on whether pain is helpful or harmful to survival right now.
Precisely.
So that's the core decision then. How does the brain calculate that life is in danger threshold? Because, if I stub my toe, my life is definitely not in danger. And that pain is immediate and, wow, intense.
Right.
What specific input makes the PEG go, okay, abort pain sequence?
It's a really intricate filtering process. The PEG integrates information from the lower brainstem, specifically the rostral ventromedial medulla, the RVM, and it gets input from the amygdala and cortex.
Which are processing fear and threat recognition.
Exactly. So if all that combined data points to an immediate, overwhelming existential threat, the system goes online. Pain, which is normally designed to make you freeze and protect an injury, is suddenly, it's maladaptive.
It's a liability.
A huge liability. The priority shifts completely from protecting the limb to protecting the whole organism.
So if we stick with that analogy, the brain isn't just ignoring the alarm bell. It's physically cutting the wire to the speaker before your conscious mind can even hear the ringing.
That's a perfect way to put it. Once that life and danger call is made, the PEG initiates what's called a descending pain modulation pathway, and the result has to be a total cancellation of pain. To do that, the brain unleashes its most powerful internal pharmacy.
Okay, let's talk chemistry, because this is where the sophistication is it's mind-blowing. We know the agents are endorphins and enkephalins, and these are often just, casually lumped into the feel-good category, but their power here is so much more targeted.
Their power is phenomenal. They are endogenous opioids. That means they're naturally produced by the body, and they are structurally similar to drugs like morphine. In this emergency context, though, they're way more dramatic than just creating a runner's high.
So tell us specifically how they achieve that shutdown. We talked about blocking the signal. How do these chemicals physically stop the pain data from moving up the spine to the conscious brain?
It happens at the synapses, mostly in a part of the spinal cord called the dorsal horn. So when an injury happens, nerve fibers release key neurotransmitters to signal that damage is present.
Like substance P.
Substance P is the big one. Then endorphins and enkephalins are released by that descending pathway from the PEG and the RVM, and they rush to bind to the opioid receptors on those ascending nerve fibers.
And what does that binding actually do?
That binding action effectively clamps down on the pain-transmitting neuron. It physically prevents the release of substance P and other excitatory neurotransmitters.
So it's like a gatekeeper.
Think of it as putting a muzzle on the signal. The electrical impulse from the injury, it still arrives, but the chemical messengers needed to jump the synapse, that gap between neurons, and continue the signal up to the brain. They're suppressed.
See, that is the crucial distinction we have to highlight here, because this is so much more than simple distraction.
Oh, absolutely.
If I'm distracted by a good book while I have a mild headache, I'm still feeling the pain. I'm just focusing elsewhere. But here, the body is preventing the very awareness of the pain signal from ever forming.
It's absolute analgesia. The electrical signal for damage still exists at the site of the injury, yes. But because the transmission of that signal is chemically blocked at that spinal gateway, the signal never reaches the somatosensory cortex.
Which is the part of your brain that processes the sensation and turns it into what we actually call pain.
Right. The brain is making an executive decision. It's saying, this signal is irrelevant data for the next 5 minutes.
That is just a remarkable demonstration of prioritization. And it brings us to the ultimate evolutionary purpose of having a system this ruthless. The source calls this the analgesic response.
Exactly. And the ultimate goal is elegantly simple: survival. The analgesic response evolved to make sure that if you get injured while you're fleeing a threat, that injury doesn't stop you.
Because if the pain signal caused you to recoil or stop running,
You die. And you take that very beneficial genetic trait right out of the gene pool with you. So it's an evolutionary contract that favors immediate escape over long-term recovery.
and we have just countless real-world anecdotes that show this chemical armor plating in action.
We do. Think about the classic example of a soldier injured in combat who just keeps operating. They're applying first aid to others, returning fire, completely unaware of a serious fracture or a shrapnel wound.
Right.
They're functioning on a temporary chemical high that is overriding physical reality. They only notice the damage once the engagement is over, and the nervous system finally realizes the threat has passed.
But I have to ask this. While this ensures immediate survival, isn't the brain kind of sacrificing the long-term health of the body? I mean, pain is supposed to protect the injury. By overriding it, the brain is actively encouraging you to do more damage to that limb.
It is a calculated risk, but in the hierarchy of needs, immediate survival trumps tissue integrity every single time.
Okay.
The brain understands that a broken ankle is manageable if you survive the tiger attack. A perfect ankle is, well, useless if you're dead. It's a triage protocol. The body provides this massive, short-term functional boost, a temporary break from common sense and physics to make sure you can complete the escape or the fight.
That brings us to a really interesting psychological tension that the source material brings up. This feeling that your own body is hiding the truth from you, that my system is deceiving me for its own perceived good.
And from a purely sensory perspective, yes, the body is withholding information, but it's doing so because in that specific scenario of an existential threat, the information itself, the pain, is the greater danger. If you consciously recognize the scale of your injury while you are still under threat, the panic, the shock, or just the natural inhibition caused by pain could make you freeze. And evolutionarily speaking, freezing guarantees death.
So the brain buys you time. It gives you the short-term strength and function. But that temporary fix means there's this massive debt building up in the background. What happens when the danger's finally over and those endorphins start to clear out?
The reckoning is swift. The brain is strapped. It's meticulous about balancing the books. Once the threat is clearly gone, you're safe. The adrenaline is dropping. The peg stands down. The source notes that the brain returns all the pain at once.
All at once.
Every single suppressed signal just rushes through the now open gateway.
And that explains that graphic, memorable example we see in disaster footage. The person walking, talking, appearing remarkably calm after an accident, only to suddenly collapse later.
Exactly. They weren't being stoic at first. They were chemically insulated. That sudden collapse is a physical manifestation of the endorphin curtain dropping. The nervous system is instantly overwhelmed by a torrent of unbuffered signals that have just been waiting in the queue. This overwhelming flood, combined with the extreme mental shock of realizing the true extent of the damage, which was hidden from you, that often triggers systemic shock, fainting, or the body just shutting down from sensory overload.
It's the moment the brain's triage committee officially closes the crisis meeting and just hands the full, brutal reality back to your consciousness.
And the body simply can't sustain function when it's faced with that level of pain signal all at once.
What a stunningly efficient process. The The brain just ruthlessly prioritizes immediate survival above everything else. Comfort, future recovery, even your own current awareness of what's happening to your body.
It literally tells the signals to wait their turn until the environmental conditions are safe enough to process them.
And it does all this using molecules, endorphins, and enkephalins that block the physical pain signal before it ever even reaches the awareness centers in the brain, which I think forces us to ask a pretty profound question about the nature of feeling pain itself.
Indeed. If the physical impulse, the electrical data, is constantly being sent from the injured nerve fibers, but it's blocked chemically at the spinal cord and so you never consciously register it, does that signal even count as pain yet?
It seems to prove that pain is fundamentally an interpretive experience. It requires processing and awareness in the higher centers of the brain. If that awareness is blocked, the pain sensation simply doesn't exist, even if the wires are still hot.
So here's something for you to think about. What does the effectiveness of this analgesic response, this true chemical shutdown, tell you about the difference between managing pain through, say, distraction versus eliminating the neurological possibility of feeling it in the first place?
How much of your daily experience of discomfort is actually interpretation versus a purely objective signal?
That's a deep dive you